Alright, so now we're just going to dive into a segment proof. Alright, we're going to prove some facts and theorems about segment, given information and what we can conclude. Alright, so let's just dive in. Let me start with this color. Given Q is the midpoint of PR. So again, I read that sentence, I immediately have to go to my picture and say tick, tick. Alright, now I know that the left side is congruent to the right side because Q is the midpoint. Alright, drawing on pictures, maybe not too important now. Maybe you can get away with it, but we got to practice these skills now while we're doing more basic proofs, because when we start to do triangle stuff and we got all kinds of information, drawing on our picture is really going to help. Alright, so Q is the midpoint of PR. The first reason is always given. Alright, so when we do a proof, there's some fun facts. How do we know our reasons? Well, what's given to us? Alright. Buzzwords. Alright. So buzzwords. It told me that I have a midpoint. Here's a midpoint right here. So I know that PQ is congruent to QR by definition of midpoint. Alright, see how I used that buzzword? I knew it was a midpoint, so I'm going to use the definition of midpoint. Alright. Also, how do I determine reasons? Well, picture. What's given to me? Do I have any buzzwords? And then just look at the picture. Alright, what do I mean by that? Well, I can tell by looking at the picture that PQ plus QR equals PR. I can tell by looking at it. Alright, I can tell that the segment addition postulate works. And this is the first geometric proof you've ever done. This is the first segment proof you've ever done. So this is probably kind of mind-blowing to you right now. Do I anticipate that you're making these connections prior to me saying this? Are you seeing what's happening before I say it? No. Alright, you're just taking in a lot of information right now. I know this is difficult. That's why we're going to spend 2 days doing this. Alright, and we're going to overcome. We're going to get really good at this. Alright. Also, maybe I said 3 or 4 previous statements. That says previous. I kind of, previous statements. Alright, so what's given to us? Buzzwords. Let's look at the picture. What about previous statements? Alright, what do I mean by that? Well, I know that those two segments are the same. Then notice how from 3 to 4, QR became PQ. That's because I substituted it in. Sob, sta, tu, shan. Alright. So just look at our previous statements, see what happens. 4 and 3 are very similar, so probably something was just substituted out, and I figured out it was PQ for QR. Alright, next what I can determine is, notice how this PQ plus PQ, I'm using previous statements again, became 2 PQ. Alright, all I did was combine like terms or simplify. Remember, you might see it either other way. You might see simplify, you might see combine like terms, they mean the same thing. You only have to write down one, but I wrote down both just to help you remember stuff. Alright, and then think, I have 2 times PQ on this left-hand side. This 2 disappeared, it became a divided by 2, that means I just did division. Alright, so that's it. That's a 2-column proof for segments. Alright, not so bad. I'm not too scared, maybe. Alright, beautiful proof. Alrighty, let's just cruise right along. How many proofs we got? Ooh, all kinds of proofs. Alright, so let's cruise right here. Given RT equals WY, so RT, so we could put a tick mark right here, but I get kind of confused because there's a lot of segments going on, so I'm just going to make a squiggly mark. This is kind of an unofficial tick mark saying that, well, the whole things are congruent. Just a lot of information going on. Then for these smaller segments, I could say, well, ST and WX are also congruent. So then, since that's the case, we need to prove RS equals XY. All right, so I drew my tick marks. Now, just let's start filling my reasons. Given. All right, now, there's no buzzword, so I'm going to look at my picture. How do I know that RT, the whole thing, is equal to RS plus ST? And similarly, how do I know WY is equal to WX plus XY? Well, that's just a segment addition postulate. I can tell by looking at my picture. I'm allowed to do the segment addition postulate. Remember, it's a postulate. It's something so simple we just accept as fact. Cool. Alright, so remember, I looked at my picture. Now, I can also use previous statements to help me create new ones. Previous statements. Alright, let's analyze this. Notice how I have RT equals RS plus ST. Excuse me. Let's look at this one instead. Minor mistake. Notice that this one and this one are incredibly similar. However, the WY became an RT. Well, hold up. They equal each other. So, since RT equals WY, and then WY equals all this junk, they must equal each other by transitive. You could technically say substitution here. I think I spelled transitive wrong. How many T's does transitive have? I'm not sure. Let's just put... That might be right. Transitive, who knows for sure. And then again, this is starting to get a cluttered mess, but we'll deal with it. RS plus ST. RS plus ST, look, it can be found here. And that equals RT. WX plus XY can be found here. And that equals RT. So RT equals RS plus ST. Let me try this thing right here, the laser pointer. RT equals RS plus ST. RT equals WX plus XY. So all that junk equals each other. They both equal RT, so they equal each other by transitive again. Transitive. I think I spelled it right this time. Alright. This is intense. Okay. Now, notice, everything's almost the same except this WX becomes ST. From 4 to 5, this WX becomes ST. Well, they equal each other from up here. So that would be just substitution. And again, this is only the second segment proof you've ever done. So you making these connections, you've seen these patterns quickly. Probably not the case. You're probably really relying on me explaining it to you right now. But the more we practice it, the better you'll get. So don't worry. And notice how this this ST is eliminated from both sides. It's just because we subtracted. All right, we subtracted a segment from both sides, segment ST, and that's how we're left with the end. RS equals XY. And we're done. Check mark, smiley face. All right, let's cram one more proof into this video. All right, we're on a nice little roll. All right. Let me think, actually. Yeah, we'll do one more. EF equals GH. All right, that's the given information. EF equals GH. And we got to prove that EG equals FH. So statement 1, given. All right, so in this particular case, the first thing I'm doing is I'm using previous statements already. Previous statements. What do I mean by that? Notice how FG is just added to both sides. I had EF equals GH, now I have EF plus FG equals GH plus FG. All I did was addition. Alright. So I know we're adding segments, but it's just the addition property, not the, you don't have to write property, but I'm just trying to emphasize thing. Because I added, you don't have to write this, it might be a good idea. I added to both sides. Alright, think about solving an equation. When you add to both sides, it's addition. Well, I added a segment to both sides, so it's addition. It's not segment addition postulate, that's different. That's when I add the two smaller to equal the whole. This, I added a segment to both sides. That's legal. That's mathematically illegal. Alright, now just to emphasize what I was just talking about, notice how now I can say EG equals EF plus FG. Alright, this one will be segment addition postulate. Because I'm adding the two smaller segments to equal the whole thing, or the big portion. Alright, now let's look at this. So to do number 3, what did I do? I just used the picture. So we have previous statements. We can tell things by looking at the picture as well. How do I know FH equals GH plus FG? How do I know that? Well, that would just be segment addition postulate again. Oops. We'll keep the 3Ds to addition, just to emphasize its addition postulate. Oops. A lot of typos going on right now. Alright, now this is going to be nuts. Alright. So, we have an EG. EG equals EF plus FG. FG, or EF plus FG is up there, and also equals GH plus FG. So this is going to end up being a massive transitive. So sometimes we can think about transitive as just being a train of statements, how I can get from one to the next. They all equal each other. So the major punchline is that I can say, well, EG starts there, FH is the end, boom, transitive. Done. Smiley face. Alright, stay tuned for more proofs.